Put your hands together and help me welcome Joel to the stage, and he's going to really tell us some interesting things about scanning the internet. So, welcome, Joel.
Thank you. All right, welcome everyone to the dangers of building a recursive internet scanner. If you're wondering what's happening over here, this is a BBOT scan, and this is basically a visualization of the scan in real time. Where each one of these little nodes is like an IP address or a host name. Basically, this specific scan right here is a scan against nasa.gov, which is a pretty big domain. Throughout the talk, there'll be a lot more of these fun little visualizations. Who all here has used BBOT, just out of curiosity? Okay, we got a couple. Okay. Intended audiences for this talk, mainly like developers and pen testers, bug bounty hunters, anybody interested in OSINT. But don't worry if you're not on this list. It's totally fine. Basically, when it comes to writing a recursive internet scanner, it's actually kind of dangerous. So if you can think of like writing a recursive scanner as launching rockets into space, this talk is basically going to be like a blooper reel of all the rockets exploding. Even if you're not a hacker, you'll probably enjoy it just for the entertainment value. Already introduced me. I work at Black Lantern Security. I've written a couple other tools, including Trevor Spray, but I'm the main author of BBOT, and also an ex-Spiderfoot dev, which I'll get into in a minute. So what is BBOT? BBOT stands for Big Huge BLS OSINT Tool, kind of a mouthful, but it's actually a lot more than just an OSINT tool. It's the recursive internet scanner that this talk is about. But in order to sort of understand like exactly what a recursive internet scanner is, it's important first to understand Spiderfoot, because BBOT was inspired by Spiderfoot. So this is where Spiderfoot comes in. Okay, so I want to tell you a quick story about how I fell in love with Spiderfoot. And just hang with me here for a few minutes till we get into the explosions. So rewind to 2020. We at Black Lantern had just started doing regular assessments for a Fortune 500 client. This client's business strategy was to acquire other companies. So whenever they had an acquisition, they would basically hire us to hack their new subsidiary. And just see how secure they were. So we did a lot of these assessments where basically the first half of the assessment was external. We'd get to do like OSINT, sort of like phishing, hacking web apps, that kind of thing. And then for the second half, they'd send us on site and we'd do an internal pen test. And this was actually really insightful because it basically allowed us to see the external side of a company, and then immediately after that, the internal side, and sort of see what was exposed and what wasn't, and like how they compared. But then we started to actually discover something really concerning, which was that there's this pattern where once we got on site and we started doing internal stuff, we would scan for a lot of the same vulnerabilities and stuff that we would scan on the outside. And obviously, we'd find a lot more of them because internal networks are typically bigger than external ones. But what was concerning was that we would find things that were vulnerable, and then when we exploited them, we would find out that they were actually exposed to the internet. But then, why didn't we find them in the external portion? So we were like, okay, how did we miss this? And it turns out that we had scanned for that vulnerability externally, but we hadn't found it because we just didn't know about the subdomain. So it's kind of hard to hack a website if you don't know it exists. So that's what we found out. So basically, this exposed some flaws in our OSINT process. We realized that we weren't finding everything. That there was a lot, sort of like an iceberg of stuff that we could have found that we weren't able to. So if I was to sketch out the process that we were using for our OSINT, this is basically it. This is typical stuff, right? You have your targets, you do subdomain enumeration with a mass, and then once you have all your subdomains, you sort, unique them, do port scans on them, and then do web discovery. And then finally, you do like vulnerability scans, like nuclei. So this was basically it. But we were starting to lose faith in this process, and I was starting to like question like how valid it was, because no matter how you sort of shuffle these around and rearrange them, you're always going to miss something. Like during web discovery over here, you're going to visit websites, you're going to find links, and those links are going to have more subdomains. So you're going to find subdomains over here that aren't going to get port scanned. So are you going to loop back? Like, how many times do you loop back again? You know what I mean? So anyway, I was sort of losing faith in our tools and questioning everything, the meaning of life. So what was missing? Like, what was missing from this process was the question I was starting to ask. So I started to look for a better tool because the tools that we were using weren't finding what we needed to. So I tested out a whole bunch of them. I would find a tool, I would like read its README, I was like, this looks pretty cool, I'd run it, and then like there'd be some weird thing that would make me really suspicious, like some subtle issue with it, and then I would read the code, and I always regretted reading the code because like it just like destroyed my faith in it, and you know, I felt uncomfortable running it after that. So and I'm not hating on tools, but if you feel like I'm hating on your tool, you can throw the shmoo ball at me. I won't be offended. All right, so we tried these. We tried Amass, the Harvester, Recon for the win, which is just like a giant 3,000 line bash script. And none of them quite did what we wanted them to. But then I found Spiderfoot. So Spiderfoot surprised me. So it surprised me with its results, but especially with its code. So when I opened up Spiderfoot's code base, I was expecting to find something kind of like the other tools, where they had like this phased approach of like, you know, first you do subdomains, then you do port scanning. But that is not what I found with Spiderfoot. Spiderfoot does not work like this. So instead, Spiderfoot works recursively, where it has where each module basically intakes a type of data, does something to it, and then outputs a different type of data. So this is a simple example here where you have three modules, SSL, CERT, Nmap, and HTTP, where Nmap takes in a host and it outputs an open port. These other two modules, they take in an open port and they output a host. So it's sort of this loop that you can see where these modules work together. There's no start, there's no end. So let's like go through a scenario, right? So we input a host name, our target, evilcorp.com. It's a host, so it goes into Nmap. Nmap port scans it, finds open ports. Okay, these open ports get fed to SSL cert. SSL cert will pull down the cert, it'll parse it, it'll find other host names, right? HTTP will visit the website, it'll find links, it'll find more host names. So we end up with more host names, which go into Nmap, which become open ports, which again go into these other modules, which become more host names, which become open ports, which become more host names, which become more open ports, and so on and so on and so on and so on infinitely, right? Okay, so this is recursion. When I saw this in Spiderfoot's code base, I knew that it was the missing piece. It like clicked, and I was like, okay, that's what was missing. So I'm going to say the word recursion a lot during this talk. And you're probably going to be sick of it, but it's very important, okay? So this is a very important concept. Okay, Spiderfoot, it did something to me. It infected me, okay? It basically changed the way that I thought about scanning. It changed my core algorithm. Like, I know this kind of sounds crazy, and it was a little crazy because this was during the pandemic, and so during quarantine, I was just locked in my apartment, like getting super obsessed with Spiderfoot. But yeah, it made me realize that like this whole time, we've been doing OSINT wrong. And these other tools that we were using, they were just like toys by comparison to Spiderfoot. Spiderfoot wasn't perfect, okay? So has anyone here used Spiderfoot? Okay, a few of you. Okay, so have you experienced the issue where it just kind of like runs forever and never finishes? Yeah, that does tend to happen. So yeah, it was a little slow. It was missing a few features that we really needed, like a good DNS brute forcer, web screenshots, a good port scanner, but that was okay. Like I was like, okay, we can just pull it the rest of the way over the finish line. We'll be good to go. So I knew it was the one. Okay, so I started by writing some modules. I wrote like a mass DNS module that had like some cool mutations where it would like have like customer-specific mutations that it would try, and it worked really well. I had an Nmap module, web screenshot, so I started to write these modules, started to integrate it with Neo4j. I was having a pretty good time. I was even able to speed up Spiderfoot by quite a bit. This is a tweet from Spiderfoot after we merged the change where basically it boosted the speed by a factor of almost 10, which was not bad. And basically, the final piece that we needed was we needed to make Spiderfoot multi-target. So Spiderfoot only supports a single domain, right, as a target. And the customers we were scanning, each one would have like 100 or more domains. So anyway, this was the last feature I wanted to implement. I was pretty excited about it. But then as soon as I started to actually do it, I realized it was going to be a lot of work, like extremely painful overhaul. And everything kind of fell apart. And not only that, there's this other thing called Spiderfoot HX, which really threw a wrench in the works because all these modules that I was writing weren't getting merged because they competed too much with the paid version of Spiderfoot. So basically I realized that I was either going to have to maintain my own fork of Spiderfoot, which I did not want to do because the code base is like 10 years old and it has some technical debt that I won't get into. But it was either that or write my own scanner. So these were my hopes and dreams about Spiderfoot. They kind of blew up and crashed and burned. But from my time in Spiderfoot, I learned a lot. This was actually really valuable experience because I learned how to write a recursive internet scanner, or at least how not to write a recursive internet scanner. I had an idea. So this was how BBOT was born, okay? And now we get to the fun part, all right? This is where the fun begins. How to write a recursive internet scanner. So my plan of attack for this new scanner was that I wanted to take the core idea of Spiderfoot. I wanted to take the recursion, and I wanted to build something for hackers. I wanted to build something that we could use on big assessments, and basically that was geared towards pen testers, bug bounty hunters, that kind of thing. And also, I kind of wanted to just write code without having to have it approved. So there's that too. So, step number one, building the core engine. So before I wrote any modules, I wanted to get the core engine working with recursive DNS resolution, just to see what that was like. It didn't take me too long to get this up and running, only a couple weeks. So this is a scan of Tesla.com. On the right, we have the terminal. On the left, we have the graph. Okay, so you can see this BBOT scan, and this is no port scanning, no subdomain enumeration, just DNS resolution, and it's only seeded with one domain, Tesla.com. So keep this in mind as we go forward, because this is what a normal BBOT scan looks like, and we may or may not be seeing some that are definitely not normal. I was pretty excited. At this point, I was feeling very, I guess, invigorated. Like after being in Spiderfoot and sort of being weighed down by all of this like technical debt, it was like a very fresh feeling, kind of like installing a new OS. When you install a new OS, everything's clean and wonderful. But there were some things coming that I did not foresee, and I didn't quite realize what I was getting into with writing a recursive scanner. So what you're about to witness are a series of disasters that I encountered pretty quickly after first writing BBOT. So same deal here, terminal on the right, graph on the left. Just watch and see if you can figure out what the issue is here. See if you can figure out what happened. Just wait for it. Uh-oh. Yeah, something's happening there. So when I saw something like this, I'd always panic. So something is clearly going wrong here. This is not supposed to happen. We could watch this, and it would keep going for some time. So what is happening here? Well, if we go and we look at it in Neo4j, so BBOT can output to multiple output sources. So Neo4j is a graph database where you can zoom in and see exactly what each data point is. So our target, which was this storeportal.levian.com, you can see that was our starting node. Then we have this giant like amalgamation of all these things. So what was it that sort of triggered all of this? If we just try, the interface is laggy because there's so many things in here. So if we could just try to find like the center one, like where did it all come from? We see that there's this storeportal.azurewebsites.net. Okay, so all right, so this basically means that in this case, what happened was it enumerated an entire cloud provider accidentally. So there's this recurring theme in early versions of BBOT where the scanner would step out of bounds, and like basically 1 minute it'd be working totally fine, and I would like go to get a cup of coffee, and then I'd come back and it'd like find it had just gone completely off the rails, and I'd like be frantically canceling it. The biggest culprits were cloud providers, which is what you saw. Basically, the client gives you a host name, and it happens to have like a CNAME record that points to a cloud host name, and BBOT just assumes the entire cloud is in scope and just enumerates the entire provider. It's also DNS wildcards. Anyone who's done OSINT hates DNS wildcards with a burning passion, and I do too. That was, if you were to encounter a wildcard domain, it would look pretty much the same as that explosion that we saw with the cloud provider. Same deal in the graph. Lots of false positives, really nasty. So let's continue on. This was a serious problem. I was not expecting to have to deal with these kinds of problems, but mostly these are sort of unique to recursive scanners. Like if you write a recursive scanner, you're going to have to deal with some problems that you would not have otherwise had to deal with. So disaster number 2, here we go. What's going on here? It could almost be like DNA replicating. Okay, but same deal here. Like this is going to run forever. It's never going to stop. And what exactly is happening? So again, we could go into Neo4j, and it would sort of like reveal what exactly happened. So let's look at it. And we'll start off, it looks a little bit different in here. So we'll start off at the beginning with our target. In this case, I just scanned the localhost. So we ended up with host name going to an open port, and then HTTPX visited the open port, and it found a URL. Okay, so we have our first URL. Pink nodes in this graph are URLs. So that URL was visited by HTTPX, and again produced another URL. And if you look closely, every single one of these URLs has a status code of 301, which is a redirect. So what this is it's an infinite redirect. Every time you hit the server, it redirects you to a brand new URL on the same server. This may seem contrived, like, oh, what a fun little demo with like a fun little graph to watch. No. We encountered this in the real world, and it was not fun to deal with. So this exists on the internet. Infinite HTTP redirect. If you visited that in a browser, you get like this redirected you too many times error message. So yeah, real thing, very painful to deal with. Okay, so starting to learn lessons here. The main lesson being that recursion is a harsh mistress, okay? The thing about recursion is that you always need an exit condition. Otherwise, it will just run forever. yeah, it'll go completely off the rails. So in the case of an internet scanner, that means that it could basically scan the entire internet if you're not careful. I'm not joking about that. Like basically, if you took off the restrictions on BBOT, it would crawl the entire internet. It would literally like resolve every DNS record. It would spider every website, like down to the deepest, darkest corner. So this concept of like restricting the recursive scanner into only scanning what you want is very important and very hard to pull off. So there were many times, I actually can't count how many times, we accidentally made a web spider. And this is like, this seems silly, but like when it comes to working in a recursive system, you only actually need 2 ingredients to make a web spider. The first one is you visit a URL, and then the second one is you extract other URLs from the response. If you have those 2 ingredients, you have a web spider. And we did that several times. Okay, final disaster. And this video isn't playing. Oh no. Give me just a second. Here we go. Okay. So this one's a little bit different. It's like a jellyfish, you know? He looks kind of cute. I don't know, just like swimming around. Okay, but don't be fooled. Don't be fooled. He's actually an unholy abomination. Okay, so if we look at this, in Neo4j, we can see what happened. And this is it. Okay, so you start off with a target, evilcorp.com, and we have some CNAME records. Okay, so we have pointing to a CNAME. Pointing to a CNAME, pointing to a CNAME, pointing to a CNAME. We have a chain of CNAMEs. But the chain of CNAMEs loops back around and ends up pointing right back at the original one. Again, this is something that should never exist, and it's an absolute abomination, but it does exist. And we encountered it, and it caused problems. So yeah, most likely, you know, someone somewhere has configured their DNS with like a CNAME loop, and they probably did it on purpose, and they're probably pretty proud of themselves. And this is why we have this meme with like the Joker burning all that stuff, because yeah, some men, you know, they just want to watch the world burn. And so let's talk about user input, okay? So we've all been told never trust user input. It's kind of been drilled into our heads. We drill it into other people's heads too. But I think that anyone who writes a recursive internet scanner or just an internet scanner will realize pretty quickly that the entire internet is made up of user input. It's literally, it's user input all the way down. And you're ingesting it into your program. That's what you're doing when you're scanning the internet. So the way to think of it is, when you scan the internet, you're fuzzing your scanner, which means you need to be ready for the worst of the worst to happen, like random edge cases, weird misconfigurations, stuff that you wouldn't expect to see, but also malicious traps that are designed to DOS your scan. And the CNAME loop is a good example of this. Okay, so what's the solution, right? Well, don't trust anything you see on the internet. It's easy to say, but it's true, and it's never more true than when you're writing a recursive internet scanner. So you will never be able to write enough if statements to handle every edge case that you encounter. Which means that you're going to have to attack them systematically, and that's what we had to do. So, so the solution that we came up with in BBOT was called scope distance, and basically scope distance just assigned a number to every piece of data that just keeps track of how far it is from the main target. So basically, the further you get out, sort of the higher the scope distance is, and the more careful we need to be with that data. So this has 2 big advantages. The first one is it puts a hard cap on these explosive edge cases, where if you have like those infinite redirects. It basically will cut it off after a certain point. The other advantage is that it lets you venture safely out of bounds to do like explorative discovery. So, this is important because you don't want to only look at stuff that's in scope. Sometimes you need to step out a little bit to enumerate sort of affiliates, that kind of thing. So here's a graphic showing like the concept of scope distance. So we have our target in green, evilcorp.com, scope distance of 0, meaning it's in scope. We have that resolving to an IP address, which is 1 hop away, so scope distance is 1. And then if we had that IP address reverse resolving to a third subdomain there, that would be scope distance is 2. So pretty straightforward. If the pointer resolved to an in-scope subdomain of evilcorp.com, it would go back to 0 and sort of reset. So in BBOT, you can tweak the DNS and HTTP distance separately. DNS by default is 2. It'll sort of like explore out to distance 2. HTTP is 0, meaning it'll only visit in-scope stuff. But if you turn it up, it'll do spidering and stuff like that. So, all right. So we're in the process of building this scanner. Our process is cyclical. It's basically we run a BBOT scan against some giant target. We see what broke and what went wrong. We fix it, and then we do it again. So this cycle continued, and BBOT kept getting better and better. So at first, almost every scan, it would do something horrible, and I'd have to like cancel it. But slowly, it started to behave better and better. And at this point, we had sort of like exercised most of the bigger demons. And BBOT, I would say, it was about as functional as like the second Death Star, right? It wasn't finished, but like it was operational. Okay, so some solutions. We came up with solutions for the cloud providers. We were able to distinguish between cloud and non-cloud assets. BBOT, when you scan with it, will automatically tag each asset, whether it's in Google Cloud. It'll tell you whether it's in Azure or all this stuff. So we were able to treat cloud assets a little bit more delicately to make sure we weren't stepping out of bounds and into this giant cloud environment. And DNS wildcards, we fine-tuned our DNS wildcard detection to the point where, yeah, basically when it saw a wildcard, it would just kill it with fire and not let it do anything. This was a lot harder to get right than I thought it would be, but yeah, BBOT's DNS wildcard detection is very good. I'm very proud of that. So every day it would get more powerful, and I started to use subdomain enumeration as a way to like gauge our progress. So this graph here. This is from 2021. This is when BBOT was just starting to pass the other tools. So you can see these other tools like the Harvester, Subfinder, Amass. It was just starting to find more subdomains than these tools. And I was starting to get this feeling that BBOT was going to be like really powerful, like more than I sort of realized. But there were still problems to overcome. So we move on into the sort of second phase of development. So BBOT was operational, but I was basically at this point trying to make it as fast as possible. I kept adding threads to the program. BBOT is written in Python, by the way. So I was adding threads to try and just squeeze as much performance out of it as we could, because we were having to scan these huge targets, and it was sometimes a challenge to get the scan to finish in an amount of time that would leave us time to actually hack the things once we found them. So we had a week, right? So we had to like, you know, if we could scan within the first day and have our scans done within the first day, that would be great. So I kept adding threads. Threading, I don't know how many of you have dealt with threads in programming, but they're slippery little buggers. So basically the threads would fight with each other, and I'd have to put them in locks to prevent them from accessing the same data at the same time, and then that would create deadlocks, and so I had to separate out the threads into separate pools, and it just became this horrible spaghetti mess of threads and locks. I started to have flashbacks to my Spiderfoot days, because Spiderfoot's threading was very much like that. I then decided to do something that you should probably never do, which is just rip it all out and start over. I did not delete all of BBOT. but I deleted all of the threading stuff, and I completely overhauled it to use async I/O. So I absolutely love async I/O, and the amazing thing about it is that instead of having all of these concurrent threads, it's just everything runs in one thread, and it uses cooperation. It's cooperative multitasking. So it's more efficient, it's less bug prone, and I love it. I would not recommend, however, doing this. I would say if you're going to write a program, pick one, threading or async. I recommend async, and stick with it. But after the async, commit, basically I deleted like a whole bunch of that code, and it simplified BBOT a lot, and it made it faster. It was amazing. So feeling good again. Okay, so at this point, I had solved sort of the weird internet edge cases, solved the threading dilemma. We're good, right? We're good now. No, actually, there's still more. I guess, remember how I said that when you scan the internet, you're fuzzing your scanner. So this is true not just for your scanner, but when you scan the internet, you're also fuzzing all of the code libraries that your scanner depends on. In other words, like the libraries that it's built with. So it turns out that when it comes to Python, the async I/O part of Python is newer than the rest, meaning it's not as mature. So Python async I/O hasn't gotten nearly as much testing or fuzzing as the rest of Python. So yeah, when we overhauled BBOT to use async I/O, we fuzzed the absolute hell out of it, and we gave async I/O the fuzzing of its lifetime. Because the thing is when you run a BBOT scan on a large target, BBOT will easily make like 10 million DNS requests over the course of that scan. During that time, you're going to find all those weird edge cases. Maybe you handled them, but maybe your underlying code libraries still have difficulty with them. So here's a montage of all the issues that I opened with our underlying libraries. We found bugs in our DNS library. We found bugs in our HTTP library. We actually found bugs in Python. We actually found a bug in the Python programming language, which I was not expecting. But this was my life for a couple months after the async merge. Basically, I was having second thoughts about async, but I actually had a pretty good experience. Like the maintainers of these libraries were actually super responsive, and like these issues, like the vast majority of them were fixed after like a week. They were just like, oh yeah, I just need to do this one thing, and then it's fixed. So yeah, I had a really good experience there. Like the developers were very friendly, and it didn't take us long at all to get these fixed. The nice thing is, all of these code libraries have thousands of other projects that depend on them. So BBOT was like able to make those underlying libraries more stable. Yeah. So okay. So I know it's not normal for someone to admit to having this many bugs in their software, right? But I think it's important because it took me a long time to learn since I was self-taught, sort of like that this is a normal process and a normal part of deving. Like when you run into a bug, when you run into a strange bug with your underlying library, it's easy to get discouraged and give up. But this stuff is all fixable, and yeah, it's important to like keep going and keep trying. So yeah, basically that was one of the main lessons I learned. And if any of those bugs make you feel anxious or uncomfortable or unlikely to try BBOT, know that we have tests. So we have good code coverage. We have 92% code coverage. We're very proud of that. Every single one of those bugs that we encountered, we wrote a test for it to make sure it doesn't come back. And yeah, it's that cycle of testing and and constant improvement that ends up creating stable software. So yeah, basically we feel very good about BBOT. Even though a recursive scanner is harder to build, it's also much more rewarding. So okay, so yeah, sort of in conclusion, I guess like the order of effort, or the level of effort was probably an order of magnitude higher than I expected it was going to be. But again, the rewards were also pretty good. So when I talk about sort of comparing BBOT to other tools, I was continuing to run these subdomain enumerations, comparing it to these other tools. Just this week, I was able to basically run all those benchmarks again. And I picked eBay.com as a target for this because it's pretty big. eBay.com is one of the bigger domains. And I just wanted to see. So this is the final result of how many subdomains all of these tools were able to find. So you can see that, when it comes to that iceberg of like how many of those hidden subdomains did you uncover, BBOT was able to uncover almost twice as many as these other tools. I should note, all of these tools actually ran pretty well, except for Amass ran for 24 hours. I had to cancel it after that. And unfortunately, Spiderfoot crashed my system after 20 minutes because it got stuck spidering eBay.com and ran out of memory. But yeah, so basically, if you're a bug bounty hunter and you're doing a bug bounty for eBay.com, just keep in mind the difference here, the difference between 5,100 subdomains and 3,500 subdomains. So that's almost 2,000 subdomains that you're missing that you would get with BBOT, which potentially, those ones are less known and possibly not even looked at yet. So, okay, so my suffering is your gain. I made this for you. Basically, BBOT is open source. It's super easy to install. You just pip install BBOT. This is the GitHub here. So yeah, I hope you've enjoyed this talk. I hope that I've been able to convey the importance of recursion. I know that as hackers, we get attached to our tools. We have our favorite tools. But I encourage you, if you're interested in OSINT, if you're a bug bounty hunter, if you're a hacker, and you use any of the other tools that we talked about in this talk, I encourage you to just take BBOT for a spin and run it on those same targets and compare the output and see if it's able to find more subdomains. So yeah, I wanted to sort of just end the talk with a fun little demo, which is turning BBOT into a Discord bot, because this is something we can all sort of appreciate. And it's important to note that BBOT is a command line tool, but it's also a Python library. So when you pip install BBOT, you can basically integrate it into your Python workflow, however you want to do that. And this example on the right here is just a little 50-line Discord bot that will essentially allow you to start BBOT scans from within Discord. This is a fun little demo here. Okay, there you go. So you can see in this demo, we actually found a vulnerability. And that's something else about BBOT is that my coworker who sits next to me in the office, Paul, he's a really good web hacker, and so he's written all of these crazy web modules for BBOT that, in addition to all of the OSINT enumeration stuff, actually are able to find vulnerabilities that get you RCE. And we've got to the point where anytime we scan a big target, it's almost a guarantee that we get one of these one of these RCEs. So yeah, ending on that Discord bot, yeah, that's pretty much it. Any questions?
How many times did your ISP shut you down?
Okay, the question was, how many times did our ISP shut us down? That's a good question. I'm thankful to say that feds never came knocking on our door. Yes, I was also pretty quick to cancel those scans when they stepped out of scope. However, we did get rate limited pretty hard. I worked pretty hard to basically make our DNS brute forcing work on these connections. But yes, so rate limiting was the biggest thing we ran into. Yeah. Anything else? All right, thanks everyone. We have stickers up here, so come get your BBOT stickers if you want them. Yeah.